This is section 6.4, capital budgeting. So we're going to start with a review of compound interest. We're going to have it a little slightly different notation. So S equals A times the quantity 1 plus I to the n. If you remember, our regular one would have been like S equals A times 1 plus R over n to the nt. It's saying the same thing, but instead of now R over n, that's going to be I. And n is just going to be the total number of times compounded. So that's the number of times per year times the number of years. S is going to be your final amount, and A is going to be your principal amount. So how much would $1,000 be worth after 1 year if interest is compounded quarterly at 8%? So we want to find the end value. So S equals, A is how much we put in, so 1,000, times 1 plus, I still like to do it with R over N to the NT. So 0.08%, so that 8% interest compounded quarterly, so 4 times a year. And then 1 year, so it's just 4 total compounding periods. So we can plug that into our calculator to get $1,082.43. Now kind of going the other way, how much money is needed today so that you'll have $2,500 after 2 years if interest is 8% compounded quarterly? So instead of being given the principal amount, we're given the final amount. So we fill in accordingly. We're looking for A, so 1 plus our interest rate compounded quarterly to the 4 times 2 because we're doing 2 years. So 2,500 is equal to A times 1.171659. And then we can divide to get $2,133.73 for our principal. So that means we need this amount of money now if we want $2,500 after 2 years. And then finally, which of the following is the better choice? So the section's about capital budgeting. We want to figure out which ones or which options are better for us. So alternative A yields a return of $2,700 at the end of 2 years plus $11,500 at the end of 6 years. Alternative B gives a return of $500 at the end of each quarter for 6 years. We're going to assume that the bank interest rate on money borrowed is 12% compounded quarterly. So let's start with A. Okay, so alternative A. Alternative A is split into 2 parts. We have the $2,700 at the end of 2 years and $11,500 at the end of 6 years. So part 1, we need to find the principal amount, okay, our current value. So our final value is $2,700. We don't know our A value. 1 plus our interest rate over the number of times compounded per year. Okay, since that's 2 years, we multiply 4 by 2. So 12,700 is equal to A times 1.26677. So we get $2,131.41 for A. Then we look at part 2. All right, part 2, we end up with $11,500. We don't know our starting value. 1 plus 0.12 over 4 to the 4 times 6 because it's after 6 years. So 11,500 is equal to A times 2.03279. And we get $5,657.25 for A. So that means our total is going to be $2,131.41 plus that $5,657.25 to get a total of $7,788.66. Then we look at alternative B. For alternative B, it's giving a return at the end of each quarter. That means it's an annuity. And it's an ordinary annuity because it's at the end of each quarter. So our monthly or our periodic payment is 500. Our N is 6 times 4, which is 24. And our I is going to be our interest rate per quarter, which is 0.03. Remember, you can use these two numbers to find our discount factor on those tables, which is 16.93554. So our present value is our periodic payment times our discount factor, which is $8,467.77. Then we want to look and say which one is larger. Alternative B is larger, so that is the route we would want to go.